Hello everyone, for this tutorial video, I'd like to explain how you can find limits that return a value of positive or negative infinity, given that we know that infinity is technically not an actual number the way the other numbers are, i.e. it does not have one specific value. Mathematically, the limit as x approaches a of function of x equals infinity if we can make function of x arbitrarily large for all x sufficiently close to the limit point x equals a from both sides like a normal limit without letting x actually equal a, again like a normal limit. By similar reasoning, the limit is negative infinity if the function is arbitrarily large and negative for all x values sufficiently close to the limit point. With that out of the way, if we are asked to evaluate the limit as x approaches 0 of 1 over x, from the right side, the left side, and the limit from both sides, we would see from the left side we are approaching negative infinity, and from the right side we are approaching positive infinity. So the normal limit does not exist because the left and right limits do not agree. If we have 6 over x squared, we take the limit as x approaches 0 of that. We see, because we have x squared in the denominator, the value is always positive, regardless of whether x is negative or positive. So in turn, this means that it is infinity from both sides, so the limit does exist here, and it is positive infinity. We are now ready to figure out more sophisticated fractions than simply fractions of x, as in this example. Although with some creative thinking, we can see it is essentially saying the same thing as if the denominator had x alone. The only difference is the location of the x. And we can confirm this with a graph. We can see, because we have x plus something in the denominator, the two one-sided limits will not agree, and so the normal limit will not exist. If we now try the limit as x approaches 4 of 3 divided by 4 minus x cubed, we can see with some rearranging it is actually negative x plus 4 cubed. So we expect the function to behave in the exact opposite way as if we had x alone in the denominator. And indeed, if we look at the graph of this function, we can see it is true, i.e. it is positive infinity from the left and negative infinity from the right. But even though the signs are backward compared to the original example, they still are different compared to each other, so the normal limit still does not exist. However, the problems become somewhat more interesting but complex if we have a variable in the numerator as well as the denominator. We can see when we study the right-hand limit of this, it is saying that x is greater than 3, and so x minus 3 must be greater than 0. And we also see in the numerator that 2 times x approaches 6 as x approaches 3 from the right. And because these two values are positive, we expect to get positive infinity as our limit. And similarly, if we approach from the left or x less than 3, we get x minus 3 is less than 0, and 2x still approaches 6, just like x minus 3 still approaches 0 from the left. So because we have a positive over a negative in this case, we expect the limit to be negative infinity. We see, because the limit from either end does not agree, the normal limit does not exist. And we can finally give a graph of this function to verify our work was accurate. However, we must remember in the study of mathematics, not every function is a polynomial, linear function, constant, or ratio of these. So we will look at other functions, such as the limit of ln of x as x approaches 0 from the right. We see from a quick look at the graph that x approaches negative infinity, so that is our answer for the limit. But it is important to note that the normal limit does not exist, because ln does not accept negative values, so it does not have a left-hand limit either. If we are told to evaluate the limit of tangent of x as x approaches pi half either from the right or left, we would again consult a graph of this. We would see from the right we get negative infinity, and from the left we get positive infinity. Therefore, the normal limit does not exist. We can also make quick shortcuts for infinite limits. In particular, if we have two separate functions, one whose limit is infinite and one whose limit is finite, we know the limit of the sum is infinite, and the limit of the difference is infinite. We know if the finite value is greater than 0, then the limit of the product is infinite, and if the finite value is less than 0, the product is negative infinity instead. Finally, if we have a finite limit over an infinite limit, the limit equals 0. As when you divide by larger and larger values, you get smaller and smaller results. Because we have stated these specifically in terms of normal limits, it is implied that this will work for one-sided limits as well. And it is also true that if the function is negative infinity instead, all of these properties will hold, except for the first three instances, the sign will be flipped. Now that we have figured out various types of limits that give infinite values, we can move on to limits as x approaches infinity in the next tutorial video. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.